Ground fault circuit interrupters, or GFCIs, are necessary in bathrooms, even if the bathroom is located within a bedroom that is protected by an arc fault circuit interrupter, or AFCI. The fundamental reason GFCIs are required in bathrooms is due to the inherent risk of electrical shock posed by the combination of water and electrical outlets. GFCIs are specifically engineered to detect any imbalances in the electrical current flowing through a circuit. If a ground fault, which is an electrical leakage, is detected, the GFCI will swiftly cut off the power supply. This rapid response is crucial in preventing individuals from receiving a potentially dangerous electrical shock. It is important to differentiate the protective functions of AFCIs and GFCIs. AFCIs primarily safeguard against electrical fires that can arise from arcing faults. Arcing faults are often the result of loose electrical connections or damaged wires. While AFCIs are vital for preventing electrical fires, their design does not provide adequate protection against electrical shocks caused by ground faults. The electrical codes implemented in most regions mandate the installation of GFCIs in bathrooms. This requirement is irrespective of whether the bedroom containing the bathroom is already under AFCI protection. This is because GFCIs offer a targeted defense against electrical shock hazards that AFCIs are not equipped to handle. To enhance safety, GFCIs should be installed within 3 feet of any water source. This includes sinks, bathtubs, and showers. Regular testing of GFCIs is essential to guarantee their proper functionality. It is recommended to test them monthly or according to the manufacturer's instructions. Repeated tripping of a GFCI without an obvious cause may signify a more significant electrical problem that necessitates investigation by a qualified electrician. Here's some more detail. A GFCI constantly monitors the current flowing to and from the devices plugged into it. It looks for any difference in current, no matter how small. Even a tiny leakage of current can be dangerous and potentially fatal. If the GFCI detects such a leakage, it immediately trips, cutting off the power to the circuit and preventing an electrical shock. An AFCI, on the other hand, monitors the electrical circuit for arc faults. Arc faults are unintentional electrical discharges that can occur when wires are damaged, connections are loose, or insulation is failing. These arc faults can generate heat and sparks, which can ignite flammable materials and cause a fire. AFCIs are designed to detect these arc faults and quickly shut off the power to the circuit, preventing a fire from starting. Now, to delve deeper into the technical aspects and relevant code requirements, let's consider the National Electrical Code, often referred to as the NEC. The NEC is a widely adopted standard for safe electrical installations. It outlines the requirements for GFCIs and AFCIs in different locations. The NEC section 210.8 specifies the requirements for ground fault circuit interrupter protection for personnel. It mandates GFCI protection for all 125 volt, 15 amp and 20 amp receptacles installed in bathrooms. This requirement applies regardless of whether the bathroom is located in a dwelling unit, such as a house or apartment, or in a commercial building. The NEC defines a bathroom as an area including a basin with one or more of the following: a toilet, a tub, or a shower. This definition is important because it clarifies the specific areas within a building that require GFCI protection. The NEC section 210.12 covers the requirements for arc fault circuit interrupter protection. It requires AFCI protection for branch circuits that supply outlets or devices installed in dwelling units. This requirement is intended to protect against the risk of electrical fires caused by arc faults. However, it's important to note that AFCI protection does not replace the need for GFCI protection in bathrooms. In fact, the NEC specifically requires both GFCI and AFCI protection in many areas of a dwelling unit. This is because GFCIs and AFCIs provide different types of protection. GFCIs protect against electrical shock, while AFCIs protect against electrical fires. They complement each other to provide a comprehensive level of electrical safety. Now let's talk about the technical differences between GFCIs and AFCIs. A GFCI works by monitoring the current flowing through the hot and neutral wires of a circuit. In a properly functioning circuit, the current flowing through the hot wire should be equal to the current flowing through the neutral wire. However, if there is a ground fault, some of the current will leak to ground. This leakage current will cause an imbalance between the current flowing through the hot and neutral wires. The GFCI is designed to detect this imbalance and quickly shut off the power to the circuit. The tripping threshold for a GFCI is typically 5 mA. This means that if the leakage current exceeds 5 mA, the GFCI will trip. The response time of a GFCI is also very fast, typically around 25 milliseconds. This rapid response time is crucial in preventing electrical shock. An AFCI, on the other hand, works by monitoring the electrical circuit for arc faults. There are two main types of arc faults: series arc faults and parallel arc faults. A series arc fault occurs when there is a break in a single wire in a circuit. This can happen if a wire is damaged, the connection is loose, or insulation is failing. A parallel arc fault occurs when there is a short circuit between two wires in a circuit. This can happen if the insulation on two wires is damaged and the wires come into contact with each other. AFCIs use sophisticated algorithms to detect the characteristics of arc faults. These algorithms analyze the current and voltage waveforms in the circuit to identify the telltale signs of an arc fault. When an arc fault is detected, the AFCI quickly shuts off the power to the circuit, preventing a fire from starting. There are different types of AFCIs available, including branch circuit AFCIs and combination AFCIs. Branch circuit AFCIs protect the entire branch circuit, including the wiring, outlets, and devices connected to it. Combination AFCIs provide both branch circuits and outlet circuit protection. They are designed to detect arc faults that occur both in the branch circuit wiring and in the cords and appliances connected to the outlets. In summary, GFCIs and AFCIs are essential safety devices that protect against electrical shock and electrical fires. GFCIs are required in bathrooms and other wet locations to protect against electrical shock hazards. AFCIs are required in dwelling units to protect against the risk of electrical fires. While AFCIs provide important protection against electrical fires, they do not replace the need for GFCI protection in bathrooms. Electrical codes mandate GFCIs in bathrooms to provide specific protection against electrical shock hazards. Always consult the latest edition of the NEC and local electrical codes for specific requirements in your area. Remember, electrical work can be dangerous. If you are not comfortable working with electricity, it is always best to hire a qualified electrician. Firstly, GFCIs and AFCIs serve distinct safety purposes. Secondly, GFCIs protect against electrical shock, while AFCIs protect against electrical fires. Thirdly, electrical codes typically require both types of protection in residential settings. 1. GFCIs are crucial in areas with water exposure. 2. AFCIs mitigate fire hazards from faulty wiring. 3. Regular testing of these devices ensures their reliable operation. Furthermore, it's important to understand the different types of receptacles and their applications. A standard receptacle is a simple electrical outlet that provides power to devices plugged into it. A GFCI receptacle, on the other hand, incorporates ground fault circuit interrupter protection directly into the outlet. This type of receptacle is commonly used in bathrooms, kitchens, and other wet locations. When installing a GFCI receptacle, it's important to follow the manufacturer's instructions carefully. The receptacle has two sets of terminals: line terminals and load terminals. The line terminals are connected to the incoming power supply, while the load terminals are connected to the downstream wiring that supplies power to other outlets or devices. It's crucial to connect the wiring to the correct terminals to ensure proper operation of the GFCI. Another important consideration is the proper grounding of electrical systems. Grounding provides a safe path for fault current to flow back to the source, which helps to protect against electrical shock. Electrical codes require that all electrical systems be properly grounded. This includes grounding the service panel, the metal enclosures of electrical equipment, and the grounding conductors in branch circuits. The grounding conductor is typically a bare or green insulated wire that runs alongside the circuit conductors. It's connected to the grounding terminals of outlets and devices and provides a low impedance path for fault current to flow back to the source. Proper grounding is essential for the effective operation of GFCIs and AFCIs. It ensures that fault current will flow quickly and reliably, causing the protective device to trip and to energize the circuit. In addition to GFCIs and AFCIs, there are other safety devices that can be used to protect against electrical hazards. Surge protectors protect electronic equipment from voltage spikes and surges. These devices are commonly used to protect computers, televisions, and other sensitive electronic devices. Arc fault indicators are devices that provide a visual indication of arc faults in electrical circuits. These devices can be used to identify potential fire hazards and to troubleshoot electrical problems. Isolation transformers are used to isolate electrical equipment from the power supply. These transformers can help to reduce the risk of electrical shock and to protect sensitive equipment from noise and interference. Regular electrical inspections are also important for maintaining electrical safety. A qualified electrician can inspect your electrical system to identify potential hazards and to ensure that it is in compliance with electrical code. During an electrical inspection, the electrician will typically check the wiring, outlets, switches, and other electrical components. They will also test the operation of GFCIs and AFCIs to ensure that they are working properly. Remember, electrical safety is a shared responsibility. By understanding the risks and taking appropriate precautions, you can help to protect yourself and your family from electrical hazards. If you have any questions or concerns about electrical safety, it's always best to consult a qualified electrician. Moreover, let's discuss some common misconceptions about GFCIs and AFCIs. One common misconception is that GFCIs only protect against electrical shock in wet locations. While it's true that GFCIs are required in wet locations, they also provide protection against electrical shock in dry locations. A ground fault can occur anywhere there is a potential for current to leak to ground, regardless of whether the location is wet or dry. Another misconception is that AFCIs are a substitute for GFCIs. As we've already discussed, AFCIs protect against electrical fires, while GFCIs protect against electrical shock. They provide different types of protection and are both necessary in many areas of a dwelling unit. Some people also believe that GFCIs are only necessary for older homes. While it's true that older homes may not have GFCIs installed, it's important to add them to any home, regardless of its age. Electrical codes have evolved over time to incorporate new safety technologies, and GFCIs are an essential part of modern electrical safety. It's also important to understand that GFCIs and AFCIs can fail over time. Like any electrical device, they have a limited lifespan and can be affected by wear and tear, environmental conditions, and other factors. That's why it's important to test them regularly and to replace them if they are not working properly. The testing procedure for a GFCI is simple. There is a test button on the face of the receptacle. Pressing this button should cause the GFCI to trip, cutting off the power to the circuit. If the GFCI does not trip when the test button is pressed, it is not working properly and should be replaced. The testing procedure for an AFCI is similar. There is a test button on the circuit breaker. Pressing this button should cause the AFCI to trip, cutting off the power to the circuit. If the AFCI does not trip when the test button is pressed, it is not working properly and should be replaced. When replacing a GFCI or AFCI, it's important to choose a replacement that is compatible with your electrical system. GFCIs and AFCIs are available in different voltage and current ratings. It's important to choose a replacement that has the same voltage and current rating as the original device. It's also important to choose a replacement that is listed by recognized testing laboratory, such as Underwriters Laboratories, or all. This ensures that the device has been tested and certified to meet safety standards. In addition to the technical aspects of GFCIs and AFCIs, it's also important to be aware of the legal requirements for their installation. Electrical codes are enforced by local governments, and violations can result in fines and other penalties. It's important to comply with all applicable electrical codes when installing or replacing GFCIs and AFCIs. This includes obtaining the necessary permits, following the manufacturer's instructions, and having the work inspected by a qualified electrical inspector. Compliance with electrical codes is essential for ensuring the safety of your home and family. It also helps to protect against liability in the event of an electrical accident. In conclusion, GFCIs and AFCIs are essential safety devices that protect against electrical shock and electrical fires. GFCIs are required in bathrooms and other wet locations to protect against electrical shock hazards. AFCIs are required in dwelling units to protect against the risk of electrical fires. While AFCIs provide important protection against electrical fires, they do not replace the need for GFCI protection in bathrooms. Electrical codes mandate GFCIs in bathrooms to provide specific protection against electrical shock hazards. Always consult the latest edition of the NEC and local electrical codes for specific requirements in your area. Remember, electrical work can be dangerous. If you are not comfortable working with electricity, it is always best to hire a qualified electrician. 1. GFCIs and AFCIs are crucial for electrical safety. 2. Understanding their differences is key to proper protection. 3. Regular testing and maintenance ensure their effectiveness. Firstly, GFCIs and AFCIs are designed to protect against different electrical hazards. Secondly, GFCIs protect against electrical shock, while AFCIs protect against electrical fires. Thirdly, electrical codes often require both types of protection in residential buildings. Remember to always prioritize safety when working with electricity and consult with a qualified electrician if you have any doubts or concerns.